idea is that what do we have in here? We have the concept of fractional
Yeah.
distillation, and we have to do simple distillation.
Mm-hmm.
All right. Now, what are
Yeah.
simple distillation and what are fractional distillation? Just understand. These are the methods to separate. These are the methods to separate the miscible liquids. These are the methods to separate the miscible liquids. Got the point? So when we are dealing with the fractional distillation part, it is used to separate the miscible liquids, right? What do you mean by miscible liquids? The liquids which can dissolve into each other. Like for example, the polar liquids will dissolve in polar solvents. The polar liquids will dissolve in polar solvents,
Yeah.
and non-polar solvents and non-polar liquids and non-polar liquids will dissolve in non-polar solvents. Are you understanding? So polar liquids
Yeah.
will dissolve in polar solvents and non-polar liquids will dissolve in non-polar solvents, right? So this is the basic idea. So when we are dealing with the concept, see, understand, no two liquids will have the same boiling point, right? So that means two liquids if we have, two different liquids if we have, both of them will have, both will have different boiling points. And because both of them will have different boiling points, why is that? Because both will have different interparticle forces of attraction. Both will have different interparticle forces of attraction. Yes or no, Vanchika?
Yeah.
So the idea is that the particles which have more interparticle force of attraction, the particles which have
Mm-hmm.
more particle force of attraction, they
Yeah.
will have higher boiling points. And the particles which have less interparticle force of attraction, they will have less boiling point. Are you understanding? The particles which
Yeah.
will have more interparticle force of attraction will have more boiling point, and the particles which will have less interparticle force of attraction will have less boiling point.
Yeah.
Are you understanding my point? The
Yes.
idea here is what? The idea here is that whenever we have this kind of situation, whenever we have this kind of situation, what is happening? So let's say if I talk about glycerine. Glycerin boils at 280 degrees Celsius. But if we talk about water, water boils at 100 degrees Celsius. That means what? That this is the boiling point of the liquid. And this is the boiling point of glycerin.
Yeah.
Am I right or not? So the idea here is that
Yes.
when we have the boiling point of glycerine and when we have the boiling point of water, what do I understand? That glycerine, if I have two molecules of glycerine, if I have two molecules of glycerine, these molecules will have strong forces of attraction between them. And when they have strong forces of attraction between them, what exactly does that mean? That they will have this force of attraction. Are you understanding? So when they will have this force of attraction, what exactly does that mean? Just tell me. That this molecule and this molecule will be holding each other very, very tightly. Whereas the molecule which
Yeah.
has lower boiling force of a lower boiling point, let's say for example, if I'm talking about ether, so if the molecule has less force of attraction, like ether will boil at let's say 30 degrees Celsius, or I will say acetone will boil at somewhere around 35 degrees Celsius. Let's suppose something like that, hypothetically.
Mm-hmm.
So then what do you expect? That the moment you open the bottle, the moment you open the bottle, what exactly happens? Just tell me. The moment you open the liquid starts to evaporate. Why? Because even at room temperature, what do you think is going to happen? Just tell me. Even at my room temperature, when we have this, okay, even at the room temperature, the molecules of acetone
Yeah.
are not holding each other too tightly, are not holding each other too
Mm-hmm.
tightly that they are not able to evaporate. So the moment you allow them to move out, the moment you allow them to vent, the molecules just start moving out. And why is that? And why is that? Because the molecules have less force of attraction. And when they have less force of attraction, what exactly does that mean? Just tell me. When they have less force of attraction, what exactly does that mean? Just tell me. That when they have less force of attraction, it would mean that these particles would kind of evaporate. Now, when we use this
Yeah.
technique, so when two liquids have a high difference, when two liquids are miscible and have a high
Hello.
difference at the boiling point, minimum how much difference? Minimum 25 degrees Celsius boiling point difference. When two liquids are miscible and they have high difference in the boiling point, that is minimum 25 degrees Celsius. You
Yeah.
understand?
Mm-hmm.
Then what do you think is going to happen? Then we separate them by simple distillation method. We separate them by simple distillation method. All right. Now, what do we do in the simple distillation method? Just understand. So, what do? We take a round bottom flask. We take a round bottom flask and we put it on the wire gauze. Under the wire gauze, we put the Bunsen burner. Okay. Under the wire gauze, we put the Bunsen burner.
Yeah.
The Bunsen burner is used to provide heat
Mm-hmm.
to the round bottom flask. So what do we have in here? We will have this liquid, this mixture. Now this mixture is not just, this is a mixture of, let's say, water and glycerin. Okay. So this represents
Yeah.
glycerin and the lighter one represents, let's say, water.
Yeah.
And what do we have in here? We are going to have this cause. You get the point?
Mm-hmm.
So what do you think we have? Got the point?
Yeah.
And thereby we have this delivery fuse. We have this delivery tube, and this delivery tube is being transported to a beaker, which is also placed over a stand. Okay, which is also placed over a stand like that. Okay, on this delivery tube is connected a condenser.
Yeah.
We have this delivery tube, and on this delivery tube, what do we have? We have a condenser like that. On this delivery tube, we have a condenser. Correct?
Yep.
And like that. Now, there is a reason why this condenser is like this. So from this outlet, we have hot water. And from this, we have inlet, which has cold water in, which has cold water in. So what is happening? Just tell me that we have this. Okay. So from here, we pass on the cold water, and this cold water is actually moving upwards. You understand? This upward movement is against the gravity.
Yeah.
So because this upward movement is against the gravity, so this water moves very slowly because it is very difficult to move against the gravity. So what do you say? It is difficult to move against the gravity. And when it is very difficult to move against the gravity, the cold water moves slowly. The cold water moves very, very slowly. And when the cold water
Yeah.
moves very slowly, so it is able to cool the walls. So this water is able to cool the walls
Mm-hmm.
of the delivery tube. It is able to cool the walls of the delivery tube. Are you understanding? And when it is
Yeah.
able to cool the walls of the delivery tube, what is happening? When it is able to cool the walls of the delivery tube, what is happening? Right? That any vapor, anything inside the delivery tube also gets cooled down. So any liquid or any vapor will also cool down. Are you understanding?
Yeah.
Will also cool down. So the idea here is what? It is able to cool the walls of the delivery tube and any liquid or vapor inside the delivery tube also cools down. Got the point.
Yes.
Got it?
Mm-hmm.
So what exactly happens? So now when we heat it, you understand both of them were at room temperature 25 degrees Celsius, both the liquids. But as we started
Yeah.
heating, the temperature rise. And when the temperature rose, what exactly happens? Just say, when the temperature rose, this temperature is going to rise upwards. And when this temperature is going to rise upwards, then what do you think is going to happen? The water and the glycerin. Water is at the boiling point of 100 degrees Celsius, and glycerin is at a
Yes.
boiling point of 290 degrees Celsius. So when glycerin is at a boiling point of 290 degrees Celsius, what do you think is going to happen? That water will evaporate. Water will evaporate. And when water will evaporate, here, because obviously the boiling point of water is 100. It is lower than glycerin, and there is a huge gap between the boiling point of water and glycerin. You understand? So when there's a
Mm-hmm.
huge gap between the boiling point of water and glycerin, what exactly does that mean? Just tell me. That when the water evaporates, what does that mean? Just tell me. When the water evaporates. So we are going to have this liquid. You understand? When we have this liquid, what does that mean? So the temperature rises to 30 degrees Celsius, then it rises to 45 degrees Celsius, then it rises to 100 degrees Celsius. And we have to remember one part that any liquid, when it is at its own boiling point, any liquid when it is at its own boiling point, what exactly is happening? The liquid molecules will have the maximum kinetic energy at its boiling point. And any liquid which is not at its boiling point will have some kinetic energy, but absolutely not at its highest kinetic energy. Are we understand? But
Yeah.
absolutely not at its highest kinetic energy. Are you understanding my point or not?
Yes. Understood.
Correct. So what is happening? So we are going to have this liquid, and this liquid will kind of evaporate. And because it is evaporating, that does not mean that glycerin is not evaporating. That is also evaporating. But because glycerin's boiling point is 290, So 100 degrees Celsius temperature will absolutely do nothing. Just imagine boiling honey. Honey will not
Yeah.
boil no matter even how, you never know how high the flame is, but honey will not boil, you know. Why is that? The reason is that the boiling point of honey is little less. You understand? And when the boiling point of honey is little higher, a lesser temperature would do nothing to it. You understand? It will simply keep simmering, but it will not literally boil. That means the boiling point of honey has still not reached. And which is why even at a
Yeah.
higher flame, you will see that it is just simmering and not boiling. Are you understanding?
Yes.
You get the point. So here what is happening? Here what is happening? So we have this liquid which is evaporating. And when this liquid is kind of evaporating, the water starts to evaporate. And the very few vapors of glycerin here. But those vapors are very few. You know, they're extremely few. And hence what is happening? These vapors reach here. And when these vapors reach here, they reach the test tube. And because we have cold water running all along the sides of the test tube, we have cold water running all along the sides of the test tube. And why is that? That water is reaching upwards. And it is forced to move upwards. Why is it forced to move upwards? Tell me. Why is it forced to move upwards? Because it has to
Because,
move against the gravity.
yeah.
And when it has to move against the gravity, the water will eventually cool down.
Yeah.
Got it? And then what do
Yes.
you think? Correct. And then because of that, the test tube or the delivery tube will become extremely cool. The walls will cool down, and hence the vapor inside the delivery tube. The vapor inside the delivery tube will also cool down, and eventually it will condense, and it will condense to form the liquid droplets. Is this process clear or not? And what do we get? Eventually, all the water will evaporate, and we will be left with what? We will be left with we will be left with glycerine here, finally, and most of the water molecules will thereby come here. Are you understanding my question? Most of the
Yeah.
water molecules will thereby come here. Understood or not?
Mm-hmm. Yeah.
Any doubts?
No.
But you also understand there's only few molecules here. Why? Because we cannot stop the molecules of glycerine from evaporating. So out of millions of molecules, if say, let's say 5, 10 molecules evaporate, they will also get condensed along with the water molecule vapors. And when they will get condensed, they will eventually land up in the beaker.
Yeah.
And when they will eventually land up in the beaker, what exactly does it? Yes or no? So that is able to cool the walls of the delivery tube, and that's the idea.
Yeah.
Got the point?
Yes.
Right. So distillation process means first evaporating and then cooling.
Mm-hmm.
Okay. So evaporating and then condensing. Evaporating and then cooling is the basic idea. Evaporating and
Yeah.
then cooling is the basic idea. Understood or not?
Understood.
Got it? So that's the idea. It is able to cool the walls of derivatives. That's the basic idea. Okay, now the question arises that first thing, the question that can be asked is that what is distillation? So you will say that if the liquids are miscible and they have a difference in their boiling points, then
Yeah.
that process is called as simple distillation. Minimum, how much difference should be there in the boiling point? It should be of somewhere around 25 degrees Celsius. Okay, it should be somewhere between 25 degrees Celsius. Secondly, what should we have? That it should have an outlet. The hot water outlet is generally outwards, and the inlet is basically going to be the cold water inlet. Are you understand?
Yeah.
It should be at the bottom.
Yeah.
The water in the condenser, and this condenser's name is Liebig's condenser.
Oh,
Okay. Then the question was that why do we have to take the round bottom flask? You can also take what? You can also take this kind of flask. But why?
yeah.
What is so special about the round bottom flask? You simply have to heat. Rather, this beaker A will settle down faster. This beaker A
Mm,
will even fit well onto the wire gauze. Yes or no? It will sit well. Whereas this round bottom flask will not sit well.
yeah.
So why is that? But the idea is that in the round bottom, so we need to take the help of a stand or a clasp to kind of hold it. And why do we need to take the help of
Mm-hmm.
a clasp to hold it? Because we need this once and oners. The round bottom flask leads to the even heating from all the sides. But whereas if I heat this, only the bottom gets heated. You understand? Only the bottom gets
Yeah.
heated. Yes or no? The point is,
Yes.
the point is what? That round bottom flask provides even heating from all the sides of the beaker.
Yeah.
From all the sides of the beaker. Am I right? It provides an even heating from all the sides of the beaker. Understood my point or not?
Yes.
Got the point? So when it
Mm-hmm.
provides even heating from all the sides of the beaker, this is what you understand from the topic that that is a need of the distillation process. But the difference between the two liquids. So let's say, for example, if I say ether boils at let's say 25 degrees Celsius, and I will say acetone, it boils at let's say 35 degrees Celsius. Now this is the boiling point. Now what is the difference in the boiling point of ether and acetone? That gap is 10 degrees Celsius. Are you understanding? So when
Yeah.
you say that that gap is 10 degrees Celsius, what exactly does that mean? Just tell me. What exactly does that mean? So we are going to have ether and we are going to have acetone. And the gap between ether and acetone here is going to be 10 degrees Celsius. Do you understand my
Yes.
point? And
Yeah.
when that happens, what does that mean? What does that mean? Tell me. Tell me.
Um.
The boiling points are very close. So once you heat them in the beaker, the moment you reach 25 degrees Celsius, obviously ether is at its boiling point. But acetone is
Yeah.
also not far away. 25 degrees Celsius, you understand the point. So what is
Yes.
happening? Just tell me. That at 25 degrees Celsius, ether is definitely at its boiling point, and ether has a maximum kinetic energy. You understand? Ether has
Yeah.
a maximum kinetic energy. But the point is, what? Just tell me.
That it got
Acetone is also
boiled.
not far away. So at 25 degrees Celsius, no wonder ether is evaporating, but
But acetone is not.
acetone is also evaporating. When acetone is also evaporating, what does that mean? When acetone is also evaporating, what does that mean? Just tell me. A huge quantity of acetone will evaporate along with ether. And when we condense them in this beaker, we will again get ether and acetone. We will again get ether and acetone. Are we understanding my point or not?
Yeah.
Yes or no?
Yes.
And because that is happening,
So
and
wait,
because
why
that is
is
happening,
acetone also evaporating?
yes. And because that is happening, we will not be able to separate ether and acetone. Are you understanding my point?
Yeah.
Got the point or not?
Yeah. got it.
Okay. So that's the idea. So simple distillation is not for liquids having similar boiling points. Simple distillation is not for liquids having similar boiling points. Simple distillation is for the liquids having a gap, a huge gap in the boiling points that one liquid automatically doesn't evaporate. So I can say that one liquid has to be thick and one has to be thin. If one is thick, it will keep simmering at a higher boiling point and then the other liquid will evaporate. Because one is a very
Mm-hmm.
sticky, thick liquid having a very, very high boiling point, and the other is a very thin, flowing liquid which has a very low boiling point. So the lower boiling point liquid will evaporate and the higher boiling point liquid will not evaporate. Are you understanding my point of view?
Yes.
Got it? Next topic comes is that let's suppose we have liquids which are miscible. Let's suppose we have a liquid which are miscible. And when we have a liquid which are miscible, what does that mean? What does that mean? Let's say we have all of them having closed boiling points. So we have a liquid, we have our liquids which have closed boiling points. We have liquids which have closed boiling point. Are you understanding? So when they have closed boiling point, what exactly does that mean? Just tell me.
Wait, give me a minute. I need to get my thoughts.
It is difficult now. Got it? So we have liquids to close boiling point. Got it? For that, we follow a fractional distillation method. Now, this method is little different. We follow a fractional distillation method. So when we have a fractional distillation method, what does that mean? Fractional distillation method is used to separate the two liquids, is used to separate the two liquids whose boiling point is too close, whose boiling point is too close, and so it is used to separate the two liquids whose boiling point is too close and less than 25 degrees Celsius to 30 degrees Celsius. If the boiling point difference is between 25 to 30 degrees Celsius, then that is a case of fractional distillation. You understand? Then that is a case of fractional distillation. Understood my point? Now, what is this logic? When it is a case of fractional distillation, it is used to separate the two liquids whose boiling point is too close. All right. So what do we happen here? So the boiling point should be very close, Minimum gap of the boiling point should be between 25 to 30 degrees Celsius. So what exactly happens? The one method and one understanding that we're going to use here is understand one thing. Okay. Let's say we have a beaker and we have some hot tea in it. Hot tea. And if I have this hot tea and I put it in the refrigerator, the temperature of refrigerator is
Yep.
0 degrees Celsius. You understand? The temperature of refrigerator is 0 degree Celsius. Am I right or not? We have the
Yeah.
0 degree Celsius refrigerator temperature and the tea is at, let's say, 70 degrees Celsius. Which has more heat? The first thing you have to understand is higher the temperature, higher is the heat. Yes or no? Higher the temperature, higher is the heat. Am I right or not?
Mm-hmm.
Any doubts in this? So more the temperature, more is the heat. I'm like, fine. But the idea is that if the temperature is higher, The heat is higher, but if we create a temperature difference, the heat tries to flow from high temperatures to low temperature, Vanshika. Are you understanding my point? The heat tries to flow from
Yeah.
high temperature to low temperature. Yes or no? Are you
Yes.
understanding? So when the temperature difference is this, so temperature difference is like this. So it tries to flow from high temperature to low temperature. Understood my point?
Mm-hmm.
Got it? So here, gradually the heat will travel, and hence the temperature of this hot tea will lower down to, let's say, 0 degrees Celsius, or will, let's say, lower down to, let's say, 10 degrees Celsius. Why? Because it has lost all of its heat to the surroundings. Are you understanding my point? Because it has lost all of its heat to the surroundings. Yes or no?
Yeah.
Got the point?
Mm-hmm.
Got the point or not?
Yes. Got it.
All right. So the idea here is what? So we are going to talk about the refrigerator, right? Similarly, just imagine. So now tell me one thing. Tell me very, very important thing. Okay. The one having higher heat. Let's say if I
Yeah.
talk about a beaker, and the beaker is already at a temperature of 50 degrees Celsius, and outside temperature is 0 degrees. And this is case A and this is case B. In this case B, the beaker is at 70 degrees and the refrigerator is at 0 degrees. Am I right?
Yeah.
In which case is the temperature difference in the inner and the outer surroundings is more? Case A or case B? Where do you think that the temperature difference in A and B is more? Case A or case B? Tell me. Where do you think is the temperature difference between A and B more? Ranchika?
Mm, in
A has a, where is the temperature difference more? 50 and 0. The gap is 50 degrees. 70 and 0
yeah.
degrees. The gap is 70 degrees. So wherever the gap of temperature is more, the heat difference is more. One at a higher temperature and one at a lower temperature.
For
Yes
temp.
or no?
Yes.
Yes or no?
Yes.
Got it? So the idea is that this gap between the two external and internal boundaries is going to be of 70 degrees and it is going to be of 50 degrees. Are you understanding that?
Yeah.
And wherever the gap is more, the heat travels faster. So more heat. So let's say in one go, let's say 100 joules heat will be transferred. Whereas here, let's say only 10 joules heat will be transferred. Why am I saying that? More the temperature difference, more is the heat transfer. So faster the liquid gets cooler down. You understand?
Yeah.
Faster the liquids get cooler down.
Mm-hmm.
Are you understanding?
Yes.
Got it? Who gives more heat? Who gives more heat? The hotter liquid. It releases a
Yeah.
lot more heat. Yes or no? It releases a lot
Yeah.
more heat. Any doubts in this or no?
No.
Now understand. So here, when we are dealing with this part, so now understand. So what do we do in the fractional distillation? We again take the round bottom flask. We put it on the wire gauze. We again have the Bunsen burner. And now, this time, we are going to connect a very special type of tower, and that is called as going to be my this delivery tube again. But this delivery tube is connected to a tower. and this is going to be my fractionating tower. So when we have this fractionating tower, what does that mean? And then we are going to have again a stand as usual. And on this stand, we are going to have a beaker being placed. So when we have this beaker being placed, what is happening? And in this beaker, in this fractionating tower, we have some beads. We have some beads.
Yeah.
Now, what are these beads? These beads are basically alumina beads. Basically, it is set of gemstones. You know, all the gemstones we have in the nature. All the gemstones we have in the nature is this. So we are going to have the alumina part.
Mm-hmm.
So when we are talking about the alumina, all right, so these are kind of gemstones that we wear, right? All of those transparent beads we have. Or it can be some PVC rings. These PVC rings are called as
Yeah.
Rashtriya rings. Do you know about the PVC pipes? Those PVC pipes that we use in home for you know, for the purpose of transporting water, or which carries water, or sometimes it also carries the electric wires. Have you ever seen those?
Yeah.
So it's like you take that long PVC pipe and you
Yes. Yeah.
cut it into several parts. So once you cut it into
Mm-hmm.
several parts, what exactly happens? You get these small parts. And these are super cooled alumina or PVC rings or super cooled marbles. All right. And
Yeah.
when we have these super cooled marbles or alumina, we will have this. Okay. Now that's super cool, super cool. And here we fill in the liquids. The two liquids we fill in here. One of the liquids is going to be this, and one of the liquids is this. But here this time, let's say we have this liquid as ether, and let's say we have this liquid as acetone.
Mm-hmm.
Or rather, not liquid or acetone. If I say this liquid is water, whose boiling point is 100 degrees Celsius, and we have this liquid as what?
Yeah.
I will call this as alcohol, whose gap is 78 degrees Celsius. Now you tell me the boiling point of alcohol, the drinking alcohol is ethanol. So it is 78 degrees
Mm-hmm.
Celsius. And then we will have water whose boiling point is 100 degrees Celsius. So this gap of 178 will be what? This gap of 178 will be what? This gap will be 22 degrees Celsius. Are you understanding?
Yeah.
And when this gap is of 22 degrees Celsius, okay,
Yep.
the liquids will evaporate. Are you understanding?
Mm-hmm. Yes.
Got the point?
Yeah.
And thereby, what is happening? The two liquids are very close. So now the room temperature was 25 degrees Celsius. And when the room
Mm-hmm.
temperature was 25 degrees Celsius, what exactly will happen? Just tell me. The temperature will start to rise. The temperature will start to rise. And once the temperature starts to rise, Eventually, the
Yep.
temperature will reach 30 degrees, will reach 40 degrees. When the temperature reaches 78 degrees, when the temperature reaches 78 degrees, what exactly does that mean? What exactly does that mean? Just tell me. That we have this thing. Got it? So here, what is going to happen? That this is going to evaporate, this is going to evaporate, this is going to evaporate, evaporate, evaporate. Alcohol will evaporate. Obviously, alcohol will evaporate more. Why? Because alcohol has reached its boiling point. Yes or no? But because
Yep.
water is not very far from its boiling point, 80 degrees Celsius is not very far off, you know. Alcohol boils at 78, water boils at 100. The gap is very less. And because the gap is very less, there will be a huge quantity of water which will be evaporating and competing to reach in the fractionating column. So this is going to be my fractionating column. Are you understand?
Yeah.
So you understand that when this liquid evaporates, so this liquid when it evaporates, it meets these cold marbles inside the fractionating column. And I hope you're understanding the vapor is hot, the marbles are cold. When the vapor travels, it transfers its heat to the marbles because the heat travels from higher temperature to lower temperature. Yes or no?
Yeah.
But at the same time, we have a huge quantity of other liquid also, which is going to be my ethanol that is also evaporating. So you tell me, ethanol is evaporating, water is also evaporating. Ethanol is at 78 degrees Celsius and ethanol is boiling at 78 degrees Celsius. But water is at 78 degrees Celsius because see, the temperature rises of the entire mixture. Am I right? So when
Yeah.
the temperature rises of the entire mixture, what does that mean? Tell me. When the temperature rises of the entire mixture, what does that mean? Tell me.
So
That we have, when the temperature rises of the entire
yeah.
mixture, water is has not reached its boiling point yet, but ethanol has reached its boiling point. And because ethanol has reached its boiling point, what does that mean? That ethanol is at its maximum kinetic energy and ethanol is carrying its maximum possible heat. But water is
Yeah.
at 70 degrees Celsius, which is not its boiling point. So definitely water is carrying some kinetic energy, which is not its maximum kinetic energy. Are you understanding my point? Yes or no? Are you understanding my point or not? Understood or not? Just tell me. So now, who is going to transfer more heat? Who is going to transfer more heat? Just tell me. Who is going to transfer more heat? Tell me. Water or ethanol? So ethanol will transfer more heat because it is at its maximum heat energy.
Yeah.
Water will also transfer energy. But you tell me, because something which has less energy and has already transferred. So who is going to condense first? Who is going to condense first? Water.
Yeah.
Why will water condense? Why will water condense? Water will condense because water is at 70 degrees Celsius, but the boiling point of water is 100 degrees Celsius. So water is at low kinetic energy, but it is still hotter than these beads. So when these water vapors they come in contact with these beads, what is happening? When these water vapors they are in contact with these beads, what is happening? Just tell me. When they are in contact with these beads, what is happening? Just tell me. That that these water vapors will lose their energy, and when they will lose their energy, they will cool down, and their vapors will not be able to cross these beads because these beads will act as a barrier. And these beads, so this water vapor will condense back and they will fall back. They will condense and they will fall back. Are you understanding? But because ethanol is at 70 degrees Celsius and ethanol is at its maximum kinetic energy, and because ethanol is at its maximum kinetic energy, what does that mean? And because ethanol is at its maximum kinetic energy, what does that mean? That ethanol will not be able to, even though ethanol is transferring energy to these cold beads, ethanol will not be able to transfer a lot of energy, and the ethanol vapors will cross, reach the delivery tube. And outside the delivery tube, we have a condenser, whereby which says what? Cold water in and hot water out.
Yeah.
Are you understanding my point? So when you have this cold
Yeah.
water in and hot water out system, so then what is happening? These vapors will eventually come here. And we will have a liquid whose lower boiling point is there. The lower boiling point liquid will be collected separately in this beaker. The lower boiling point liquid shall be collected here in this beaker. Are you understanding?
Yeah.
And when we have the lower boiling point liquid, which is being collected here in this beaker, what does that mean? When we have this lower boiling point liquid, which is being collected in this beaker, what does that mean? This is called as my distillate. The distillate is one
Mm.
which gets collected in a separate beaker. All
Yeah.
right.
Yes.
But you understand that this is not a single case, The first round, imagine the first round, that the vapors they start to evaporate. In the first round, both, because the beads are so cold that in the first round, the beads are so cold, so chilled, that both water and ethanol will condense fast. Nothing is going to pass. So round one, nothing evaporates. Round one, nothing evaporates. Nothing crosses the fractionating constant. So round one, when nothing crosses the fractionating constant, what does that mean? So we are going to have round one and nothing crosses
Yeah.
the fractionating column. And both ethanol and water they condense back. Both ethanol and water they condense back. Are you understanding my point? Got the point?
Yes. Yeah.
But you understand that when okay, so that is the case of round one. Second case, what happens? The beads they have gained a lot of energy because water and ethanol, both of them have transferred their energy to the beads. And because water and ethanol, they have transferred their energy to the beads, what is happening? The beads have, the beads are not so chilled or not so cold this time. Now, next time, but they're still cold, but not so cold, you know? So next time when another, round of evaporation happens and both ethanol and water evaporates, what is happening? This time, ethanol is at its highest kinetic energy. It is not being able to condense, but water is still having lesser energy. Why water is having lesser energy? Because water is evaporating at 78 degrees, but ethanol is boiling at 100 degrees. Ethanol is boiling at 70 degrees. So the one which boils has higher energy. So the one which has higher
Yeah.
energy, it's very difficult to control the boiling cheese, but the boiling component and the water will still have lesser energy. So water will be able to transfer its energy and to the less chilled beads and the water will condense back. So eventually in the second or the third cycle, you will see water rising to evaporate. But once it meets those colder beads, it condenses, it loses the energy, the heat energy to those colder beads, condenses back. Ethanol also has a lot of energy. Ethanol also gets condensed back, But a majority of the ethanol is not being able to condense back. And that ethanol goes into the other delivery tube, crosses the fractionating column beads, and gets condensed because of the water running in the Liebig's condenser in the upward direction. Are you understanding my point?
Yeah.
So this way you are able to get here water, and this way you are able to get here ethanol. Are you understanding us?
Yeah.
Got it?
Yes.
So that's the idea we understood.
Yeah.
That's the idea we have.
Let-
Any doubts in this?
No, let me just finish writing.
The component which is left at the back is called as a residue.
Yeah.
All right.
Yeah, I'm done writing.
All right. Any doubts in this?
Mm-hmm. No.
So this is the concept of fractional distillation. So likewise, if I give you a mixture, let's say if I have benzene and toluene, so you should know few liquids whose boiling points are so close, okay, that if the gap is less than 25, if the gap is less than 25, then probably they will be able to, okay, if the gap is between 25, then they will be able to do what?
Yeah.
We will be able to separate them with fractional distillation. So this column is capable of, forcing back one component back to the round bottom flask and allow the other liquid to reach the other side of the beaker, which is where we are collecting the distillate. All right. So that is the idea. All right. Okay. So that's it for today, Vanshika.
Yeah.